I want to test the theory that we invented for this differential equation in the last movie. So this is the Matlab file that corresponds to the differential equation. As we talked in class, this is a function which returns dy dx given x and y. And the function says that dy dx is equal to minus x squared over x squared plus 5 times y plus 6 over x plus cosine of x. And now I just want to run it and see if our theory works. So to do that, then what we do is as we said before in class, is that we simply type this command. We will describe this command to you how it works a little bit later on, but for now, basically it's integrating the equation from x equals 0 to 100, and it's using an initial condition of 3. So I just hit return, it runs that, and now I can plot the solution, and here it is. You see it starts at 3, and then the solution decays like 6 over and 1, and we think that it should decay like 6 over x. So now I'm going to show you a little trick to basically to compare the two. So what we can do is the following thing. If I type plot ty, and then I plot another two variables to plot, so I can plot sec t and 6 over t. So if I do this, and then replot it, then here it is. And I need to sort of zoom in so we can look just the part of the solution that we see. And what you see is that, in fact, the green line here is our loss 6 over t, and you see that at large x, it indeed agrees very well with 6 over t. One thing I want to point out, and this is a Matlab trick, is that when I divided the y variable for the second thing I'm plotting, I use this funny dot divide, which is what you have to do if you're dividing a set of numbers, a number by a set of numbers. So another way of actually doing the same thing is we could have made a log-log plot. So here actually I'm plotting t and y, and then I'm plotting t and 6 over t, and I'm going to actually use an open circle to represent the 6 over t, and here's the result of that. And so what you see is indeed on a log-log plot, the initial condition ends up going very nicely to this 6 over t log. And just to sort of show you how great this is, let's be pleased with ourselves. We can do this hold all trick that I said in class, and then rerun it with different initial conditions. So I don't know, let's say 20. So it's the same thing, different initial condition, and we can again plot. So we can again do log-log of this. Let me just do log-log of the solution. And so there's the new solution. You see this is the red curve. It starts out at 20, and it also goes to 6 over t. So this altogether shows that using our computer, that our 6 over x log was indeed correct.